welcome to my channel Learning with Khatak. In the last lectures, we have covered a topic that how a neural network works. If we look at the slides, that's how here we defined the different layers, how interconnected with each others. Here we have shown that neural networks can be used for binary multi-classification problem, and also we can use it for binary classification problem like that. And then we have discussed that that is called a multi-layer perceptron. Why? Because if you look at this, there are multiple layers, and inputs flows from input layer to hidden layer and then output layer. So then we also discussed that if we are going to use here a sigmoid functions, then how this sigmoid functions will be calculated, the threshold value, and how this sigmoid function will decide this which inputs will be triggered for the next layer. This is the just true cap of the sigmoid functions, that how sigmoid functions will be used and how mathematically it will be represented. Similarly, then using these examples, we practically have shown that how a sigmoid functions will be used and how the sigmoid functions calculate the inputs to be triggered or not. Similarly, the sigmoid function used here at the output layer will decide the importance of the input, that how much this input is important and which inputs will be triggered to the final output layers. Then we will just a little bit discuss the backpropagation network, but anyhow we will develop a separate video lectures for backpropagation networks. Now in this part, we will look at how to predict a house price by using neural networks. So these are the just some inputs, x1, x2, x3 and x4 are different inputs. Now the problem is predict the price of a house. Now if you look at in a real life, if you want to sell or if you want to buy a house, how you can decide to buy a particular house or not? Obviously we will look at some features of the house, for example square feet area of the house. So if I label these inputs with the features of the house like that, x1 represent let's suppose we are saying that x1 represent the square foot area, then x2 represent the number of rooms, the number of bedrooms in the house, and x3 represent let's see the number of floors, and then x4 the number the age of the house, means it is old, new, or how much old it is. So if you look at this, the input layer, and now these are nodes in the input layers. The input layers accept the inputs like area of the house, bedrooms of the house, distance to city, how much the house is far away from the city or main market, and then age of the house. Then this is how much it is built after before 5 years, before 1 years, a brand new house, what is the age of this house. So this is the input layer. Input layer accepts inputs, takes inputs from the data sets. These are the basically features of the data sets. House predictions, if you look at the house prediction data sets, these are the different features inside the data sets. And then the output layer will be obviously based upon some criteria, some conditions, different weights are assigned. For example, area, we assign a weight w1 to this input. Let's suppose we say that we are require 500 square feet house. If we find a 500 square feet house, we will assign a weight w1. For example, that will be our dream house, so we will assign a maximum weight to that. Similarly, we are requiring that in 500 square feet house, the number of bedrooms should be 5. So if there are number of bedrooms, 5 number of bedrooms, then we will assign maximum height. If there are 3 number of bedrooms, then obviously we will assign less than weight less than w1. Similarly, distance to the city, miles. Obviously this is the most important features, inputs. How a weight will be decided? So if the house is far away from the city, then obviously it will we will use is a less weight. But if the house is nearly to the city or to the main markets or to the main market, then obviously this features has a maximum weight. Similarly, if the house is branded, maximum weight will be, we will assign a maximum weight. But if it is old than a 5 or 6 year, then obviously the weight value will be decreased here. So based upon these weights, we will decide that whether we have to buy or not this house. Similarly, now there are only one layer, input layer, and second one is the output layer. Now since there are multiple layers in the neural networks, so if we introduce another hidden layers, how this will be look like? So before hidden layers, these are just the introductions as we discussed in the first lectures, that several layers may be there. Input layer, information from the outside world enters the artificial neural networks from the input layer. Input nodes process the data, analyze or categorize it, and pass it on to the next layer. Obviously, if you look at this, these informations are come from the outside world. Here in this node, we analyze all these features, all these informations, the nature of data, that is the categorical data or numerical data or something else, means we are normalize here all these features, all these external world data are normalized here at input layer, and then this layers will analyze or categorize it and pass it into the next layer. So if you look at this, after properly analyzing at the input layer, these inputs are triggered to the output layers, assigning some weights, importance of the inputs, that how much importance we have to given to the area and how much importance should be given to the bedroom, number of bedrooms, and then how much importance should be given to the distance between the house and the city. And similarly, if the house is branded, then obviously much weighted will be given. If it is old than 5 or 10 years, then the weight factor will be less. Okay, then hidden layers. Hidden layers take their input from the input layer or other hidden layers. Artificial neural networks can have a large number of hidden layers. Each hidden layers analyze the output from the previous layer, process it further, and passes it to the next layer. So keep in mind, if you look at this, hidden layers take their input from the input layer. So if you look at this, this is the hidden layers. Now this hidden layers will take input from this input layer. How these inputs will be then? Okay, networks, each hidden layers analyze the output from the previous layer, process it further. Now here activation function will be used inside the hidden layers node, in the node of the hidden layers, which will process it further. Means based upon some threshold value, they will decide that the input should be triggered to the next layers and pass it to on the next layer or not. And then output layer, obviously the output layer gives the final result of all the data processing by the artificial neural networks. It can have single or multiple nodes. Means if there is a binary problem, then obviously it will give us a 0 or 1, and if it's multi-class problem, then the output may be in a different classes. Yeah. For instance, if we have a binary yes no classification problem, the output layer will have one output node which will give the result is 1 or 0. However, if we have a multi-class classification problem, the output layer might consist of more than one output nodes. Okay, then what is deep neural network architectures? Keep in mind one thing, that we are covering the basics of neural networks in order to make forward to the deep neural networks. Our basic aim is to cover the deep neural networks, how the deep neural networks will be implemented, how different problems will be classified using deep neural networks. So deep neural networks or deep learning networks have several hidden layers with millions of artificial neurons linked together. A number called weight represents the connections between one node and another. The weight is a positive number if one node excites another, or negative if one node suppresses the other. As we discussed previously, nodes with higher weight values have more influence on the other nodes. Obviously, if some nodes or some inputs have higher weights, means these inputs have more importance as compared to the other nodes. Theoretically, deep neural networks can map any input type to any output type. This is important point to be noted. However, they also need much more training as compared to other machine learning models. Obviously, the data sets for a deep neural networks have a huge number of samples, a huge number of data, and the training time obviously requires a much more time for the training of the data sets. They need millions of examples of training data rather than perhaps the hundreds of thousands that a sample networks might need. Okay. Now, if there are only two layers, input layers and then output layers, there is no hidden layers, then based upon this the price will be that how much the price will be. So the price will be predicted upon weight 1 multiplied by x1. So means how much weight is given to this input, then plus weight 2 multiplied by x2, number of bedrooms and the weight assigned to the number of bedrooms. For example, if number of bedrooms are 5, then maximum weight will be given. If number of bedrooms are 3, then or 2, then minimum weight will be given. So obviously, if you look at this from here, the weight is a positive number if one node excites another, or negative if one node suppresses the other. Node with higher weight value have more influence on the other node. For example, if you look at this, these are the different nodes x1, x2, x3, x4. Every one node is multiplied with the proper weight. So if let's say we can say that the weight of x2 is maximum. Obviously, if the weight of x2 is maximum, more important will be given to node x2 input. So if number of bedrooms, if the house have 5 number of bedrooms, then obviously we will be more interested to buy this house in the price. Similarly, so since there is no output layer, there is no concept of activation function inside the hidden layers, but here inside this output layer there will be an activation functions. This activation functions will decided that which input should be triggered or which input should be given more importance. So if we introduced a hidden layer inside, obviously there must be a hidden layer. So now these inputs then first move towards the hidden layers along with their proper weights, and then from there activation functions will be used, and then activation functions will decided which nodes to be moved, which information to be moved to the output layers. So if you look at this now, each 4 attributes or four inputs are forwarded to the this node, and similarly some weights will also be assigned with this. So if you look at this, some weights are also assigned, and here if you look at this, there is a activation functions is used. A Relu activation function is used. A Relu activation functions, if you don't have a background of Relu activation functions, please consult with the lecture number 3 of neural networks, where we have covered in detail how Relu activation function will be used. Similarly, this is the Relu function is that the main catch here is that the Relu functions does not activate all the neurons at the same times. The neurons will only be deactivated if the output of the linear transformation is less than 0. So if you look at this, this is the neuron is deactivated if the output is equal to 0, and the neurons will be fired, activated if the value becomes more than 0. So if the value is here, if you look at this, the value becomes more than 0. So that's why here in this case the neurons will be triggered, or the input will be triggered by the this Relu activation functions. So if you look at this, there may be a different activations functions, Relu activation functions that will be used inside the hidden layers to decide which input should be given more important to the output or price predictions. So this is now the price, and this price will be based upon the activation functions here applied in the output layer. This activation functions will use these inputs along with their proper weights to decide which inputs should be given more importance and which inputs should be given less important. So in this part we have covered a practical examples by predicting a house price. Different features are discussed of the house. These are the different features of the house, and these features are basically input to the input layer, and then how the weights will be calculated, how the weights will be assigned, and then these weights and inputs will be used inside the hidden layers. Activation function will decide which inputs have to be triggered to the next output layer, and so on. So thank you very much.